We can now use both sets of data to track the mean, median, mode, and range of both of the students' points. So we've got Sean's points first. These 12 numbers needed to be added up and then divided by 12. And I must tell you that I used a calculator on this. So Sean's points averaged to 87.6 points maybe per day. There are 12 numbers. Maybe both the students had opportunities to get points on 12 different days. And so the mean would tell us that Sean averaged 87 points, basically 87.6 points per day, whereas Warner averaged about 85.16 per day. The bar over the 6 means the decimal repeated. So I didn't put it all on there. We know that that is a repeating, both had repeating decimals. That's just how the math worked out. Okay, the median, mode, and range, I left that for us to work together. In Sean's case, let's do our range. We have 72 and 105. Those are our highs and lows. So it's basically a subtraction problem. So we've got 3 and 3. There's a range of 33 on Sean. And for Warner, we've got 117 was our high point, 65 was the lowest. So the range was 52 for Warner. Let's look at our data set to find the mode. That's the mode, the most. So the most often number on Warner has a repeating number here with 2 87s. Everything else seems to owe 2 94s. So he has 2 modes. That would be 87 is a mode, and so is 94, because the data points both had 2 in it, everything else had 1. Sean doesn't seem to have any repeating numbers at all on his, so his mode is the empty set. It doesn't apply. So you could put NA on that, or this empty set sign. The median is the middle term. Okay, so we can do high, low, high, low, high, low, canceling them out that way. We know that there are 12 items in each of these sets. So if we divide 12 by 2, we would get 6. So we could count over 6 from the lowest number. 1, 2, 3, 4, 5, 6. Here's this number right there would be 6 from the front, from the lowest, and then counting backwards, 1, 2, 3, 4, 5, 6 here. So 88 and 89, these two would have to be averaged. Because they're right next to each other, we can easily tell that 88 and 89 would give us a middle number of 88 and a half, or 88.5. So that would be the median of this set of data for Sean. Over here, let's count again. 1, 2, 3, 4, 5, 6. Here's 6 from the highest, and now we're going to count 6 from the lowest. 1, 2, 3, 4, 5, 6. This is the next one. So we have 88. I'm sorry, we have 85 and 87. So what number comes between them? That would be 86. So 86 would be our calculation. We actually didn't have to do the calculation on that, but if we did, we would add these two numbers together, 85 and 87, which would give us 172. And then 172 would be divided by 2, and we would get 2 goes into 17 8 times. That it would be 16, and there's 1 left over, and 2 goes into 12 6 times. But those were easy enough that you could also do them in your head. So when you've got a huge data set of statistics, the stem and leaf plot really does help order them easily. If you have one set of data, you can use a single stem and leaf plot, but you can also track 2 sets of data at the same time by using a double stem and leaf plot.